Good morning, everyone. I am Gautami. Today, my topic is electronic polarization in the subject of engineering physics. Introduction to electronic polarization. Electronic polarization refers to the displacement of electron cloud within atom or molecule when exposed to an internal electrical field. It plays a sequel roles in determining the electric properties of materials. Understanding electronic polarization is essential for applications in electronics, optics, and material science. Polarization of light from basics of instruments in less than 100 slides. Difference of polarization states of light. Light has an electromagnetic wave. The mathematically and graphically representation of polarization. Linear circuits, elliptical light, polarized, unpolarized light. Basic concepts of polarization. Polarization is defined as the electric dipole moment per unit volume of materials. It can occur through various mechanisms including electronics, ionic and orientational polarization. Electronic polarization specifically involves the dispersion of electrons clouds relative to the nucleus. Mechanism of electronic polarization. When an external electric field is applied, electronic are displaced slightly from their equilibrium positions. This displacement creates an include dipole moment within the atom or molecules. The magnitude of electronic polarization depends on the polarizability of the electron cloud. Polarizability and its facts. Polarizability is measured of how easily the electron cloud an atom or a molecule can destroy. Uh, it depends on the size of atom and molecule and the number of electrons present. Larger, the more diffuse electron cloud tends to have higher polarizability. Polarizations has three types: electronic polarization, orientation polarization, ionic polarization. Oriental polarization have two, one hydrogen, second oxygen. Ionic polarization in anion and cation. Every polarization have electric field. Quantitative description of electronic polarization. Electronic polarization occurs when an external electric field disturbs the electron cloud around atom or molecule, creating a temporary dipole moment. When an electric field E is applied, P P is equals to alpha E, where P is equal to induced dipole moment, alpha is equal to electronic polarization. E is constant depending on atom or ion. E is applied electric field. Electronic polarization alpha shows how easily the electron cloud can be disturbed. Dielectric constant and electronic polarization. The dielectric constant Epsilon of an material is influenced by electronic polarization. If quantifies the material's ability to reduce the effective electronic field within it. Higher electronic polarizability generally leads to a higher dielectric constant. Frequency dependence of electronic polarization. Electronic polarization occurs at every high frequencies, typically in the ultraviolet range. It is most instantaneous, responding quickly to changing electric field. This frequency depending in the important in understanding optical properties of material. Experimental measurements of electronic polarization. The techniques such as dielectric spectroscopy measure the frequency depending dielectric response. The polarizability can be differs from the dielectric constant at higher frequencies. The precise measurements help in the design materials with specific dielectric properties. Applications of electric polarization. Electronic polarization underpins the designs of capacitors and insulating materials. It is circuital in the development of optical devices and sensors. Understanding electronic polarization aids in controlling materials of specific electronic and photonic applications. Summary and key takeaways. Electronic polarization involves the disturbance of electronic clouds in response to an electronic field. It is discharged by the polarizability of atoms and molecules and occurs rapidly at higher frequencies. Mastery of electronic polarization concepts is virtual for advancing materials science and electronic engineering. Thanks for giving this opportunity.